The global tourism industry depends on a difficult balance. It generates trillions of dollars by bringing millions of visitors to the world's most pristine natural environments. But visitation has a physical cost. Every person who enters a fragile ecosystem causes a degree of immediate, unavoidable destruction. This creates a central paradox for the industry. The sheer volume of visitors required to sustain local economies can eventually degrade the very attractions people travel to see. For these areas to survive, administrators must apply scientific management frameworks that strictly govern how humans interact with the land. The specific framework an administrator chooses determines whether these ecosystems can withstand the pressure of global tourism, or if they will be lost to permanent degradation. Historically, park managers relied on a rigid quantitative model known as carrying capacity. The logic is simple: establish a strict numerical cap on visitors. When headcount hits that threshold, it triggers an absolute physical cap, making gatekeeping predictable. However, enforcing an exact mathematical limit is nearly impossible in a dynamic natural environment, where variables are constantly changing. A flat headcount doesn't account for how people actually behave. A small group of destructive visitors can cause more ecological damage than a much larger group of visitors who stay strictly on established paths. Because a simple headcount fails to capture these nuances, relying solely on carrying capacity can give environmental managers a false sense of security. Managers eventually pivoted their strategy, moving away from counting people at the entrance and toward analyzing the actual physical condition of the terrain. This evolution led to a more flexible strategy known as limits of acceptable change, or LAC. LAC shifts the focus. It ignores theoretical headcounts and instead continuously measures the real physical impacts occurring on the ground. This framework uses a sliding scale to determine how much environmental change is tolerable. If variables like soil erosion reach a certain point, managers intervene. It allows managers to set different thresholds across a park, accounting for areas that are hypersensitive. By focusing on biological damage rather than an arbitrary numerical quota, LAC provides a more accurate reflection of the environment's true health. While LAC is flexible, it works best when layered over a rigid baseline capacity, allowing managers to use the strengths of both frameworks. In fact, managers achieve the highest level of environmental protection when they utilize carrying capacity and LAC in tandem. The primary obstacle is often institutional. Many parks lack the funding and resources necessary to deploy both systems simultaneously. But when properly resourced, this two-pronged approach provides a pragmatic method for allowing tourism and ecosystems to coexist. However, even these combined frameworks have a limitation. They are reactionary. They are designed to manage the damage of a tourism venture that is already underway. True sustainability requires a tool that can predict environmental effects before, during, and after a venture breaks ground. Next, we will consider environmental impact assessment.